Hi, I'm Jack Buffington for robotbrigade.com. This is another video in my series of videos about a open source mapping robot that I've been working on. And in this video, I'm going to talk about my first stab at a microcontroller node that runs under ROS2. I am not claiming to be an expert at ROS2. There are some things in this code that I personally consider a little bit clumsy, but I haven't learned enough about ROS2 to figure out how to do them properly. So I give it to you under no warranty. Let's just jump right into the code and we'll look at the header file for my microcontroller node. Here I have some standard C++ pound includes. These two are things for ROS2, and these two are include files that I have found useful over the years that I include in many of my pieces of code. These are constants that I'm trying to not have as magic numbers in my code. This is currently uncalibrated. I am just taking a rough guess at how many are in each meter, but this will be useful at some point in the future when I want to drive at exact speed or accelerate at a known rate. Here are some function definitions. And then the node itself is organized as a class. And I will get to all of that over here. This is the C++ file. Typically in my code, I have at the very beginning how you're going about compiling the file, and then how to run it. And here is an example of how you would publish to a topic that, well, this actually won't work, but it's publishing to the beep topic, but in the data, this would actually be 0 or 1, but it's showing how to publish on a topic in general. So here I have my constructor, and these are callbacks that when I publish from another node or from the command line on a topic, then these callbacks get called. Here is how I'm doing my serial data in this node, and I'm not sure if this is the best way to do it, but it's how I'm currently doing it. Ideally, I'd love to have it so that when a byte came in, it would just have a callback by itself. But in the quick research that I didn't find something native to ROS that had that functionality. So instead, what I've done is I've created a timer that runs 20 times per second and calls this serial callback timer, or serial timer callback, that I will explain a little bit in a few minutes. And these are when the microcontroller sends a message to the CPU, I want those messages to show up and be published on topics relevant to each. And so when I send a battery voltage from the microcontroller, it posts on the battery voltage topic. So the structure that I've chosen to do here is that when I receive something on a topic, I split up the message, and then I'm actually calling a separate function to implement the low-level details of communicating to the microcontroller. And here's where I'm doing something that's possibly a little clumsy. I am splitting my data apart using a delimiter. And in this message here, I'm using a tilde to split things apart. So this is the display message topic that I'm listening on. And in this one, I want to publish on a row and a column. And then here's my message. And so I'm splitting it using split string, which is a function that is in my commonly used functions C++ file. And I'm splitting based on the tilde. Then I assign the values to row, column, and the message, and passing that off to the send text to display function. Same with beep, same with drive motors. And CPU ready, I'm no longer actually using that, so I probably should just get rid of it, and it'll likely be gone by the time you see this. But maybe not if I forget to do it. So here's the serial timer callback. And like I said, it happens 20 times per second. And it is implementing a state machine to keep track of where it is in a message. So the first thing that it does is it's looking for a header byte. And in that case, it's the decimal value of 85. Once it receives that, it sets the state to 1. It was previously a state of 0. And setting up a couple of initial values that it will need. Now it receives the next character and assigns that to how many bytes are in the message. And that byte represents how many bytes will be after the bytes in message byte, including the checksum. And then next, in the next state, I receive that many bytes, so bytes in message bytes. And when it has received that many bytes, it checks the checksum. So the checksum's being computed at each step when it receives a byte, and it's doing that using the exclusive OR of each received character with the cumulative exclusive ORs of all the characters that have been received. And because the way I'm computing this, if the checksum has checked out, the resulting value after it has received all of the bytes will be 0 if it received it correctly. So I'm checking that here, and then I'm parsing the message. So the next thing would be the message type within a message, or the first byte within an actual message is the message type. And so here I'm saying, okay, it's button presses, and I publish to the standard out that it's received how many button presses. So if I go 1, 2, 3, it'll say received a button press message, and it'll say 3 presses. Then I am publishing on the button press topic with the message, which is basically the same thing that I just wrote to the console. Battery voltage. I am representing the battery voltage as the voltage times 1,000 because the propeller microcontroller does not have floating point. So, I mean, it can implement it, but natively it doesn't. And so things are much faster if I just use a decimal representation. So I'm taking all of the 4 bytes and adding them together with the appropriate bit shifts to get the value that I'm looking for. Then I divide by 1,000 to get it into the actual voltage. I display to the console what that was, and then I'm creating a message and publishing on the battery voltage topic. The main program, basically I found that when I was compiling this, it wasn't always updating. I'd make a change and I'd be like, why the heck is it still not working? And it turned out to be that it wasn't compiling the most recent thing. It was getting confused. So I started putting in which version it was, but I think this is not necessary now because I figured out that if I just deleted a certain file or two, then it would go ahead and completely recompile. The script that I was using should be in my GitHub repository. The next thing I do is I set up my serial port so I can receive and send those messages. And then I am initializing. So what this is RCL++ is, where are we doing this here? It's basically what I'm basing the node off of. So I'm inheriting from RCL++. And I'm doing the spin, which makes it look for all those callbacks, and that's the main loop that it's running then. And then presumably ROS2 has a way of shutting down a node, in which case this would get called, but I don't actually know what happens in that one. Then finally down below here, these are the functions that I was calling from my callback functions, and these compile the actual messages that are sent to the microcontroller. I'm adding the bytes in, I'm computing a checksum, and then I'm sending it out. So the same thing for the rest of these. I will leave the serial port stuff and commonly used functions for you guys to explore. They're a collection of routines that I've found to be useful. I will say that in the serial port stuff, there is a function in here somewhere, receive message, get message from serial port. I'm not using that in this particular program. This is just sort of a general purpose library that I have, and there are likely others that I don't have as well, or that I'm not using as well. But anyway, that is my microcontroller node. It does work. Everything has been tested. So hopefully you find this useful. If you do, you might check out my other videos on this mapping robot. And for robotbrigade.com, I'm Jack Buffington.